Now we want to talk about how you can figure out the formula of an ionic compound, what that formula unit is based on the ions involved. And so this is going to be based around the idea that all ionic compounds are overall neutral. This is going to be an important fact that even though you have, say, cations that are charged and anions that are charged, overall it has to be neutral. It's neutral because of the idea that basically each atom or each formation of ionic is based on the transfer of an electron. Right there. So if an electron leaves something, that becomes a cation, and it goes to some atom that becomes an anion, there has to be an equal change in charge. You get one positive on the cation, one negative on the anion. So when you have a particular set of atoms or ions that you're going to form a compound out of, the ratio of those different types of atoms is decided in order to yield no net charge. It has to be neutral overall. So for example, sodium and chlorine. So sodium is plus, chloride is minus. So we can see that their charges are equal and opposite, right? They're both one, they have the same magnitude, they're just going in opposite directions. So the ratio of 1 to 1, just NaCl, yields an overall 0, because basically we have 1 times plus 1 and 1 times negative 1. That gives us an overall neutral charge. In the case of putting aluminum with fluoride, aluminum is 3 plus, fluoride is minus 1. Now we can see that in the formula unit, we have unequal numbers of atoms, of ions, because they have different charges. We can see that each aluminum is big, right? Each aluminum is plus 3. It has a large size of charge, so we only need one of them. Whereas we only have one of them, but for the fluorides, it's only minus 1, so that's a smaller size charge, and as a result, we need to have 3 of those anions. We need more of the lower charge. So one aluminum is plus 3, and then we need 3 of the fluorides at minus 1, and that overall, they cancel each other out, leading to a neutral overall compound. And we can take these ideas and come up with what the ratio is always going to be. In order to determine that formula, we can work through an algebraic process, but instead, I prefer to use what's called the crossover method. This is just kind of an algorithm or an approach that when you have the ionic formulas, it lets you figure out what the overall formula is going to be for the compound. And so it's based on, you write out the ions, what the formulas for the ions are, and then you basically take those charges, you move them, turn those numbers into subscripts, and then simplify it. So let's walk through an example. We'll look at that aluminum and fluoride. And so we can see that aluminum has a plus 3 charge, fluoride has a minus 1 charge. So what I do is I take the charges and I move them to the other atom as subscripts. So the 3 was on the aluminum, that becomes a subscript on the fluorine. The 1 was on the fluorine, that becomes a subscript on the aluminum. Now we don't write the 1, but it's there as a subscript. Importantly, we don't care about the charge. So we don't have like a 3 plus as the subscript on the fluorine or a negative 1. We only care about the magnitude of the charge. 1, 2, 3, 4, 5. We don't care about the positive or the negative. And so you can see, just like we didn't write a number there, we also don't write the number on the aluminum. But we just move those numbers onto the other side. Basically what we're reflecting is things that have a large charge, like say the aluminum here, large 3 charge, means we're going to need more of the other atom, right? The other ion, because we're going to need more to balance out the charge of the large charge of, say, the aluminum. So we're going to need more fluorines. So that's the motivation for doing this crossover, for moving those charges as subscripts on the other atom. So that's step 1 and step 2. You kind of do them at the same time. Step 3 then was simplifying. And when we're talking about simplifying, I have a 1 to 3 ratio. What is the ratio of atoms? So this is 1 to 3. As a fraction, that'd be 1/3. So when we're talking about simplifying, we're talking about like simplifying fractions. You can't simplify 1/3 anymore. So AlF3 is where we're at. If we look at something like Ti4 plus and O2 minus, we can move them over. We can see that the 2 from the O is now the 2 on the oxygen, and the 4 from the titanium is now 4 on the oxygen. You will note that these numbers, we only take the numbers, not the positive or the negative or anything like that. And so I have Ti2O4. And what I've done right now is guaranteed that this is overall neutral. But remember, formula units need to also be simplified. If I look at my ratio, it is 2 to 4. That is not simplified. I can divide both of my subscripts by 2. So that would be 1 to 2. Basically divide the 2 by 2 gives you the 1 on the titanium. Dividing the 4 by 2 gives you 2 on the oxygen. So this, the arithmetic or the process here is really simplifying a fraction. I had 2 to 4 or 2/4 that can be simplified as 1/2 or 1 to 2. All right, so let's look at another example. What is the formula of the ionic compound formed between Ba2+ and O2-? So if I want to come up with a formula of an ionic compound, we're explicitly told it's an ionic compound. So we know we're going to be able to use our crossover method if we need to, or we can use our crossover method. So write the charge of the cation as the subscript on the anion, write the charge of the anion subscript on the cation, basically just swapping where they are. And so we can move them. And so what ends up happening is the 2 here becomes the 2 here, and the 2 here becomes the 2 here. And so we can see that they're moving right across each other. In this case, they were the same charge, but it works out. And then the final step is to simplify the subscript ratio. Right now, my ratio is 2 to 2. Okay? Those are the same number, right? So 2 divided by 2 is the same thing as just 1. Okay, and so we can see that we can simplify it. And this is, so we can always follow this process, just moving them across and simplifying. We can also take a step back and think about, this is similar, this overall ratio that we've ended up with is 1-to-1 ratio. And it's similar to what we saw for sodium chloride, right? The NaCl that we were talking about. And that was +1 and -1. Here, we can see it's +2, -2. So it's the same idea that these charges are bigger, the barium is bigger, and the oxygen is bigger, but they're still equal in magnitude. So if you have one +2 charge and one -2 charge, you're going to cancel out and be neutral overall. Participation 6.5, question 1. What is the formula for the ionic compound formed between CO3+ and F-? This is the first question on participation 6.5 due Friday, June 5th at 11:59 p.m. over on Blackboard. Link to the assignment is right below the links to these videos. Again, what is the formula for the ionic compound formed between CO3+ and F-? Okay, so we want to move this a little forward, complicate it a little bit. What is the formula of the ionic compound formed between aluminum and sulfur? So we know we're still looking at ionic compound formulas. So we still want to do the crossover method. Write the charge of the cation as the subscript on the anion. But here we've reached a bit of an issue. Okay? What's the cation and what's the anion? Right? Previously, we've always had the charges given to us, and now we don't. But we do know what the atoms involved in, or that are contained in the compound are going to be, aluminum and sulfur. So we can take what we've learned previously and figure out what the ions are going to be for these elements. So aluminum, it's a metal, which means we know it'll form a cation. Aluminum is one of those special 3, aluminum, zinc, and silver, that just has a charge. Aluminum is always 3+. You can't really figure out based on the periodic table, but it is just always going to be 3+. So we know it'd be Al3+. Sulfur is a non-metal, so we know it's going to be an anion. It's in group 6A, which means it's always going to be -2. So we know that we're dealing with Al3+ and S2-. Now we can go through the process of swapping my subscripts. Let's get their colors. The 3 goes from the aluminum to the sulfur. Again, I don't take the charge. The 2 from the sulfur goes to the aluminum. We just take those numbers. And then the question was simplify the final step, simplify. Well, 2/3 already is simplified. We're good to go. So this is full on doing some chemistry, right? We can have two elements, aluminum and sulfur. And we can say, if aluminum and sulfur are going to form an ionic compound, what will the formula of the compound be? You know, one of the ways you could approach that is you could just do an experiment and analyze your compound and figure out all that kind of stuff. Or in this case, we can just avoid doing an experiment and just know it's going to be Al2S3. That's going to be the formula for every ionic compound formed between the elements of aluminum and sulfur, because aluminum is always 3+, and sulfur is always S2-. And because of those rules, because of the rules for forming ionic compounds, we just know what that ionic compound formula is going to be. Look at us, we're chemists. Okay, we got our first question for participation 6-5. Looking for any more of those. It's going to be due on Friday the 5th. Just getting started on a set of videos, plenty more to go. See you in the next one.